In this video, we will learn how to find confidence intervals for the population mean using samples of size less than 30 called small samples. In a random sample of 5 people, the mean driving distance to work is 22.2 miles and the sample standard deviation was 5.8 miles. Assume that the random variable x representing the population of all driving distances is normally distributed, and construct a 95% confidence interval for the population mean and interpret the results. Note that it is appropriate to use the t-distribution for this problem as the three assumptions of the t-distribution are satisfied. Namely, the sample size is small, the sample has only 5 people, it's less than 30. Secondly, the population or the random variable x is normally distributed. And thirdly, the population standard deviation is unknown. We can assume this because what's given in the problem is the sample standard deviation of 5.8 miles. So it is appropriate to use the t-distribution. The first thing to do is to identify the numbers given in the problem in terms of symbols so that we can substitute them appropriately into the formulas. So 22.2 miles representing the mean driving distance is x bar as it comes from a sample. 5.8 is the sample standard deviation of the same sample and that represents s, and the sample size is 5 because there are 5 people in the sample. Now the first step to do is to find the TC value, the critical value from our t-distribution. So let's draw the t-distribution and try to understand what we are looking for in the t-distribution. Note that this t-curve has 4 degrees of freedom because the sample size is 5 and the degrees of freedom is always n minus 1, or in this case 5 minus 1, 4. So TC here represents the value on the horizontal axis or the t-axis, and we are looking for the value of TC so that 95% of the area under the t-distribution is between minus TC and plus TC. Now, to find the TC value using the t-table, all we need to know is the confidence level of 95% and the degrees of freedom, which is 4. So let's take a look at the t-table, and across the level of confidence we locate 95%, 0.95, and look down below that under that column and across the degrees of freedom, which is 4. So across 4 and under 0.95 we see 2.776. So that is the number we will be using as the TC value. So TC in this case is equal to 2.776. The second step in the problem is to compute the margin of error. The margin of error is given as TCS divided by the square root of n. So substituting all of these values, which we know, we have 2.776 times s, which is 5.8, divided by square root of n, that will be square root of 5. This gives us, using a calculator, we will have 2.776 times 5.8 divided by square root of n, so that's the square root of 5, and that gives us 7.200. so we will write 7.200. I like to round to 2 decimal places unless otherwise stated, so we have 7.20. So the last step is to compute the 95% confidence interval. So the 95% confidence interval for the mean for mu, the population mean, is given by the formula x bar minus e to x bar plus e. It's given by this interval. So x bar we know is 22.2. So 22.2 minus the error which we calculated as 7.20, comma 22.2 plus 7.20. And that comes out to be equal to if you used a calculator, we would have 10 minus 0 minus 0 is 0, 2 minus 2 is 0, so we'll have 22 minus 7, that's 15, comma, and here we will have 29.40. This number here is 2. So this is a 95% confidence interval for our population mean. And how do we interpret this answer? We can say that we are 95% confident that the population mean of driving distances lies between 15 miles and 29.40 miles. So what this means is that if you repeatedly took samples of size 5 from the population of all driving distances, then 95% of the sample means will fall between 15 miles and 29.40 miles. And that completes the problem.